Welcome to Technically You, the podcast that makes cybersecurity, tech, and innovation easier to understand. So, have you ever wondered why your internet just works when you plug in that Ethernet cable? The technology behind it is like an intricate dance of politeness and mathematics that changed how computers communicate forever.
That's such an interesting way to look at it. And what most people don't realize is that without this elegant solution called CSMA/CD, our early computer networks might have collapsed under their own weight.
Let me paint a picture of what networking looked like in the late 1970s. Imagine an entire office building where every single computer was connected to just one cable, like having 100 people all trying to talk through the same tin can telephone.
Well, that sounds like a recipe for complete chaos. How did they possibly manage all that traffic?
That's where CSMA/CD comes in. Carrier sense multiple access with collision detection. Think of it like having the world's most sophisticated traffic control system, but for data instead of cars.
So how exactly did this system keep everything from falling apart?
You know those polite dinner party conversations where everyone listens before speaking? CSMA/CD works similarly. The carrier sense part means computers listen to see if anyone else is transmitting data before they jump in.
But what happens when two computers accidentally start talking at the exact same time?
That's where the real genius comes in. The collision detection part. When two computers detect they've talked over each other, they both stop and wait a random amount of time before trying again. But here's the clever bit. If they collide again, they double the possible waiting time.
Oh, wow. So it's like if two people at that dinner party spoke simultaneously, instead of both jumping right back in, they'd each flip a coin to decide who waits?
Exactly. And if they somehow still spoke at the same time again, they'd flip two coins to wait even longer. This system, called binary exponential backoff, keeps doubling until the computers eventually transmit at different times.
It's actually quite brilliant in its simplicity. But I imagine this system started showing strain as networks grew larger.
You're right on the money. As networks expanded, having everything in one collision domain became problematic. It's like trying to have 1,000 people all talking in one giant room. Chaos.
So what was the solution to that growing problem?
Well, that's where network engineers got creative and developed bridges and switches. These devices essentially created separate conversation spaces, like breaking that giant room into smaller meeting rooms where smaller groups could talk without interfering with each other.
And that development led to what we now call full-duplex Ethernet, right? Where devices can send and receive data simultaneously?
Precisely. And here's something fascinating. While modern networks don't really need CSMA/CD anymore, its principles fundamentally shaped how we build networks today. It's like the DNA of modern networking.
That's really interesting because it shows how sometimes solving an early technical challenge can have ripple effects for decades to come.
And speaking of ripple effects, let me share something mind-blowing about the timing requirements of CSMA/CD. The system had to account for how long it took electrical signals to travel through copper wire. We're talking microseconds here.
So the actual physics of electricity through metal influenced how they designed these networks?
Exactly. And that's why there were strict limits on how long Ethernet cable segments could be. Too long. And the collision detection wouldn't work properly because the signals would take too long to travel back and forth.
Well, that explains why early network cables had such specific length restrictions. I always wondered about that.
You know what's really interesting? While Ethernet with CSMA/CD won out over competing technologies like Token Ring and AirSnet, wireless networks faced similar challenges but needed a different solution.
Oh, right. Wi-Fi uses CSMA/CA instead, doesn't it? With A for avoidance rather than detection?
That's right. Because detecting collisions in wireless signals is much harder than in a wire, Wi-Fi tries to prevent collisions from happening in the first place. It's like having an invisible traffic controller coordinating everyone's transmissions.
The evolution of these technologies really shows how engineering solutions often have to adapt to different physical constraints.
And here's something that really puts this all in perspective. Every single time we plug in an Ethernet cable or connect to Wi-Fi, we're benefiting from these elegant solutions developed decades ago. It's like standing on the shoulders of giants.
That's such a great way to think about it. Sometimes the best technology really is the kind that becomes so seamless we forget it's even there.
Well, as we wrap up this journey through networking history, I think it's worth remembering that behind every simple click or download lies an incredible tapestry of engineering solutions that made our connected world possible.
And maybe next time our internet connection acts up, we'll have a bit more appreciation for just how complex these systems really are.
Absolutely right. And how something as simple as listen before you talk could be transformed into a mathematical algorithm that helped build the modern internet. Now, that's what I call elegant engineering.
That's it for this episode of Technically You. Smash that subscribe button, share with your students or IT team, and tune in next time.
And as always, stay curious.